Alright, so let's recall some lines. What do you guys remember about lines? You all were all on board just a minute ago. You were like, I remember all the things about lines.
Slope-intercept.
Okay, there's a thing called slope-intercept.
Yeah.
Y equals mx plus b.
Don't be sorry, that was good.
Okay.
So y equals mx plus b, which part is what?
This.
And the slope.
You don't have to defer to him, you know?
Well, I just felt bad because I was answering all the questions, so I just wanted to give somebody else a chance.
Don't worry, I'll tell you to shut up if you're
B is
answering.
the
all
y
this.
intercepts.
Okay. And what do x and y stand for?
Grid.
Your input and output.
Yeah, those are kind of the input and output here. You guys good with this one? Remember this one? Okay. How do you graph one of these?
So you take the y-intercept, and then you move from that point where the slope tells you to move.
Okay, so which axis does the y-intercept go on?
The y-axis.
Vertical.
Yeah, it's the y-intercept, right? So that's where it intercepts the y. So that'd be up here. So there's like b high, right? Go up b. And then slope,
Rise over run.
nice, is a rise over a run, right? So I think about this as a fraction, right? So if that was 4 over 3, right, I'd do
Up 4 to the right 3.
up 4 and right 3. Since this is m, I'm going to think about that as,
10 over 1.
exactly, I'm going to think about that as m over 1. So I'm going to go up m and over 1. So I'm going to have up m over 1 and another dot here. Please note that could be, doesn't have to be up, right?
Be down, no, to the left.
Could be down if the number m is negative, right? You guys all see that? And then you kind of connect the dots and make your line like this. All good on that? Okay. That's slope-intercept. What other forms you got?
Point slope.
Yep. There's a point slope, which is
Y minus Y plus Y minus Y2 Y1 Y1 minus
I think you got the right thought. Y
Y
equals. And then this part should be,
oh, it's the second part of the quadratic, right? Or the b squared minus y over.
no, you went too far, man. Quadratic land's too far. Come back with us to line land. So this should be, let me put an m here,
Yeah.
and then add some symbols to help.
Yeah.
So you're going to say
Keep going.
x. You're going to
X minus y.
Oh yeah.
Y minus x.
X minus
X
x,
X2 X1.
sure, x2, x1, x naught, whatever. And then plus y1. This one might be a little unfamiliar. Anybody a little new for this guy?
I don't really remember that.
Okay, so this is the same thing as this guy, where instead of having the intercept, you have instead some other point.
Isn't that also written as y minus y1 over x minus x1 equals m?
No,
Yep.
See, that's what I was saying.
No, but isn't that's how you find the slope, is doing the difference in y and the difference over x, and the point slope formula would be.
Okay, so he said something that sounded a lot like the formula for slope that wasn't quite the formula for
Okay.
slope. So another way you could phrase that, or another way you could think about this, is your thought of m is y2 minus y1 over x2 minus x1, right?
Right.
That's really, oh, cool, new piece of notation. If you haven't taken a class with me, my math sometimes thinks things,
It's great.
right? So when you look at this, you might think rise over run. You guys all good with this notation?
Yeah.
Okay, I'm going to use this a lot. Right, so there will be lots of little thinking bubbles. Sometimes they'll get a few stacks deep and things will get confusing. If you get confused about what's thinking bubbles and what's not, say so and I'll write the thinking bubbles in a different color or something. Alright, so what Robert said was you can rephrase this as m equals y minus y1 over x minus x1. Which looks and sounds a lot like this formula for slope, but is not quite the same thing because,
We're solving for x and y.
yeah, this is x and y are the unknown variables, and this is assuming you know m. You guys with me on that? Alright, so we have slope-intercept, we have point-slope. There's another one that you probably didn't see in Algebra 1 or 2 that's called standard form. I like the AB, yeah. So this is
Ax squared.
ax plus by equals c, I think is the usual.
Quadratic sound over here.
Let me, yeah. So, these guys are a little bit different looking, but they're the same information. Right, if you want to get this to look like slope-intercept, what do? Yeah, move stuff around, right? So you subtract the ax and then divide by b. Let's go to that. The standard form has the very slight advantage that this allows for vertical and horizontal lines to be written in standard form. You can't write a vertical line in slope-intercept form, it doesn't work. You see that? Why?
It's not like,
The slope's all jacked up, right? Because a vertical line has a slope of
0.
close. That's a horizontal line.
It's
Yeah, a
undefined.
vertical line has a slope that's undefined.
Yeah.
Right? So let me quick throw vertical and horizontal in this business. So what's a vertical line?
Undefined.
It's got an undefined slope, right? It's not a function. But if I wanted to write an equation for a vertical line,
X equals 0.
yeah. So vertical line is like x equals some number. Right, like if I was writing this in standard form, that'd be x equals c. Or ax equals c, right? Those are both standard form. You guys go with that? What about the horizontal? Or sorry, yeah, what about the horizontal? Yeah, that would be the other one. That would be y equals c. Guys good with these? So, very slight advantage in one weird way. They're a little bit harder to draw. They're kind of, like this form is kind of funky to deal with. It does lend itself to some of the other stuff we're going to do later, so I'd like you to start fiddling with it now, and I'll kind of use it as a template in a couple of spots later. Cool? For right now, it should feel just a little awkward and kind of forced, because you're so used to this one, right? You're like, line, y equals mx plus b, check, I know things about this. It's a good thing, it's okay. Alright, I got one more. The other one is definitely new. So a parametric line is one that I'm going to do by example. So here's an example of a parametric line. X is 1 plus 2t and y is 3 plus t. That seems weird. Why does this seem weird?
Two variables that you have to solve
Yeah, there's all of a sudden a new variable in the mix, it feels like there's too many. Okay, so the difference between a parametric line and other lines is that the parametric line comes with a direction and with some kind of path information. In other words, you can think about walking along a parametric line and your speed is kind of prescribed. In these other guys, there's no direction, there's no speed that's prescribed there. So this is actually more useful. This is what I use when I'm like firing lasers or launching things in space. These guys, not so much. Those just describe the path. That describes the thing, right, with a time attached to it. What's up?
Can I use a different variable than a t?
Absolutely. Is that because your t's look like plus signs?
Yeah.
Yeah, so if you want to use a different variable, go for it. Or if you want to decorate your t, have at it. I very much like little hats. I just like hats. It's just a personality thing. But if you want to put some other little decoration on there, feel free. Or if you want to call it S, go for it. W? Terrible choice. No, that's fine. Sure. It should be noted that's not a traditional choice. No, it's all good. You can keep your W. Don't let me rain on your parade. You just don't use a smiley face or something. It gets complicated. I had a buddy who did that. We'll talk about it later. There's a story. Failed his master's class. Okay, so here is the cool thing about the parametric equation. If you plug in a time, right, a t, like think t is 0. What are x and y when t is 0? 0. T is 0.
Yeah, just throwing it out there.
So when t is 0, you have 1 plus 2 times 0. Which is 1, right? Okay, so if I'm sitting here, I'm thinking, alright, t is 0. X is 1 plus 2 times 0 is 1. And y is 3 plus 0 is still 3? Okay, so that means when t is 0, we're over 1, up 3. So, over 1, up 3, dot. That dot comes when t is 0. You see that? So that's where this action starts. When t is, say, 1, what are we at?
4.
X is 3,
Y is 4.
and y is 4. Okay, so I go over 2 in the x and up 1 in the y. You see that? Dot here. That dot corresponds to time 1. If I trust that this is a line, do I have enough here? Yeah. Right. If I trust it's a line, then I know what this line looks like. It looks like this. What's special about this one? I know which way time runs. Doesn't go backwards. So, I know that this line goes that way. You guys see that? This line was a little special. It came with it. That's the direction in which this line moves. Still the whole line, right? Because t could be negative. You can think about something that happened a while ago. Right? So you still get the whole line, but now I have a time moving forward. Cool? Questions, Steele? What's the slope there?
Just like a 1.
So when I went from here to there, I went, my x's went from 1 to 3.
So 1 half.
Yeah. So I had 2 in the x and 1 in the y. So the rise was 1, and the run was 2. So this is a slope of 1 half. Where else could you see that? There's a tricksy way to find the, there's a tricksy way that I can take the t's out of it and go find that thing. You guys see it? How do you get the t's out of it?
Subtracting that.
Kinda. Subtract was good. Subtract what from where?
The 3.
Okay, so I'm going to take this guy, I'm going to subtract 3 from both sides, so I'm going to get y minus 3 is t, right? Okay, so now I know what t is, it's y minus 3. Plug it in somewhere. Where is it t?
And then just equals to t.
Yeah, the x one's got a t, right? So I'm going to take this y minus 3, I'm going to put that up here, shove it in for t.
I don't know, do
You see that? No? Yeah, good. Okay, so out of that, I get x is 1 plus 2 times
Y minus 3.
times all of, right, y minus 3. And then we have to warm up our algebra skills again.
Distribute.
And remember to distribute. Right? So we get x is 1 plus 2y minus 6. And then that is pretty darn close to this. Right? Or you guys can manipulate to that. Do you want to see the rest of that, or are you okay?
You subtract x, add 6 to the sides.
What else? Yeah. Alright, let me go through it.
Why is that 2y minus 5?
Okay, so I think where I'm sitting from right there is I have x is 2y minus 5, right? Actually, it's like, yeah, man. So if I want to get that into slope-intercept, my kind of default line form. Yeah, you kind of need to divide by 2 eventually, right? You want to do it now or in a second? After? So what do you want to do first? Add 5 to both sides? Why are you adding 5 to both sides? What's your motivation? It's the way I was taught. You want to get the y by itself, right? Right, because this form has y equals stuff. So if I want to get that y by itself, first thing I'm going to need to do is get the 2y by itself. So I get the 5 to the other side. So I got 2y is x plus 5. And then what? Divide by 2. Okay. And you guys are in one of the varsity classes, so you're going to get to multiply by a half. Same thing, right? So you got y is 1/2 x plus
5 over 2.
5 over 2. Because you remembered to distribute. Please don't feel bad if your algebra is a little bit rusty. It's all good. Summer's long. Feel good. Get it back. Just takes a minute. Does that look like what I had over there? Yeah, I kind of. It looks like I kind of was off on my line, right?
Yeah, you do like up a half.
Yeah, so I think my line maybe should have been more like through there, but that's a pretty believable error, right? You guys cool with us? Okay, so parametrics are just a touch different, but are more or less this familiar thing. Good with this?